In the case of Intel, the Intel specification is actually a chip and a chipset, the BIOS that you find in your PC, etc. In the case of ARM, ARM is actually a specification of an instruction set. So ARM that's used on all the phones, ARM that's used on an iPad, ARM that's used on some other tablets, ARM that will be used and supported in Windows 8, is actually just a specification of a chip. The actual chip depends on the vendor that manufactures the chip. But in the case of ARM, they don't have a BIOS. ARM does not have a standard display. So we've had to redesign Windows dramatically to be able to deal with some of those core issues. And so the result of that is that Microsoft makes some key bets. A key bet is when you really bet the company on it. It means you're investing in it. Today in the cloud, so far, we've probably invested a little bit less than $4 billion in engineering for the cloud. Building out data centers, building out software to either support the cloud or run in the cloud. New hardware types, and hardware is different kinds of CPUs, different kinds of devices, mice, Connect. Those are all new kinds of hardware that we're sort of aggressively involved in. I'll come back to natural interfaces. Again, we invest both on the enterprise side, but also on the consumer side, and sometimes allow those things to blur between one another. I'm closer to the mic. There you go. Okay. I don't need the mic, actually. Oh, I do. All right. First-party applications, as we've decided that we need to invest in Office running on Windows machines, but also Microsoft applications running on other platforms. We make more money per Macintosh than we do per PC because of the success of Office on the Mac. Every Mac user uses Office on the Mac. And so we've also looked, Skype runs on lots of different places. OneNote runs on everywhere. SkyDrive, which is a cloud storage service, now runs on an iPad and iPhone. So we will selectively decide on when to place Microsoft technology on other platforms. The idea of that is actually having the customer being tied to the cloud service and the identity and not necessarily only to the device. Let me play you a video that talks about some next generation user experiences. And hopefully the sound will play. No, it's not. Hang on. His name is Sasha. He's actually Polish, so can you read Polish? Can you break out of the video? There you go. Press play.
There's a camera and a projector combination. The camera captures the video of my surface and sends it to the remote end, to the remote projector, and the camera on the remote side captures the video of the remote surface and sends it to my projector so that I can see what's going on that side. What I have here is an IllumiShare device pointed down at my table, and it's currently illuminating an area in front of me. And this illuminated area is shared with my friend Keen, whose video you can see in the Skype connection in front of me. Now, Keen could be really anywhere in the world, but for the purposes of this video, he's sitting right behind me so that we can capture his and my side at the same time. Now, Keen and I are going to start off by playing a game of tic-tac-toe. I'm going to draw the board, and then Keen is going to start with his X in the middle. I'm going to put an O below it. He's going to go there, I'll go here. And you can see that he won the game. Now, in addition to drawing and playing games, we can also share objects that we have anyway that we want to either just talk about or play with. So for instance, if Keen and I are playing a card game, I could throw down some cards, and Keen could do the same. He can also take some dice and roll them. And to make sure that I know that he's not cheating, he rolls them on his shared area so I can see the dice that he rolled. We can also compare objects such as toys. So I know he has got a Hello Kitty, and there it is. And I'm going to put my toy next to his Hello Kitty, and then we can talk about them and compare them. Another interesting aspect for IllumiShare is that it enables children to get math or science homework help from a tutor who is remote. So for instance, Keen can be my tutor, and he's got a math homework worksheet for me through which I'm going to work. And so I'm going to say 1 plus 1 is 2, and 3 minus 2 is 1. And you can see as I'm working, Keen is evaluating my work, and 5 minus 2 is, I'll say, 3. And that's actually wrong. And so now I know as a child that I need to work on my subtraction of negative numbers. So what we've seen here is a LumiShare, which is an innovative device that allows remote people to share arbitrary physical or digital objects on any surface. It works well with existing systems for video chat such as Skype to provide delightful experiences through a hardware and software combination.
So this was a video that we released a couple months ago that talked about some work from Microsoft Research. What's interesting that's happening in this picture is that the user experience is actually moving from typing and digital and numbers going back to analog. So the computing power is strong enough now where we can move from a digital world to an analog world, because the way people used to communicate was with writing. And what this does is allows people to share work surfaces between two people, actually more than two people, and collaborate in a very natural way without knowing that you have to sit down at a keyboard, type, click a mouse, open a window. Those things are gone. The way you open a window in this case is you take a piece of plastic and move it aside and you've got a new window. And so this looks interesting, but this is brand new research about ways of allowing people to interact with one another. And if you've tried working with a Connect, it's the same idea. Connect is actually about people working with one another in an analog world as opposed to a digital world. And so lots of research that's happening in this space. My screen is locked. Can you try it? There you go. So let's think about tomorrow. There really are two key themes of a lot of the research that's going on today. The first one is about the connected cloud. And then the second one is about connected devices and the user experience on those devices. So let's talk about user-centered computing. We know some very interesting things about the ability of the brain to adapt to user interfaces. I've got a little device. It's a remote control. They gave it to me earlier. Had to teach me that the two arrows meant left or right. There's some other buttons over here that I don't know what they are. But you can learn, your ability to learn this device is actually fairly simple. It's one device, and if I use it at another meeting later today, I become an expert in how to use this device. So over time, the brain adapts, and it takes something that is new and maybe complex and makes it simpler. Here's some examples of single-purpose devices that are very interesting. The one on that side, you'll find in most airports and a hotel, it dispenses paper towels. It's very interesting watching people use it, because not everybody knows how to use it. The way you use it is you walk up and you wave your hand. There's an infrared detector, and it dispenses a towel. You want another towel? You wave your hand, and it gives a towel. But if somebody has never seen it being used, there's no instructions on there. How do you know that you should wave? So if you watch, you'll see people grab a towel and try and pull it out, and it doesn't always work. But if you just watch somebody do it, it's amazing how you can learn. The same is true of the other example here, which is you've got a shopping cart full of stuff, you've been to the supermarket, and you're walking through the door. And as you approach the door, there's an infrared detector above the door, and as you're rolling your cart, the door opens. It's magic. But what happens if the infrared is not there? Watch somebody the next time you go to a supermarket, because they'll bash it against the door, they'll try and kick it from the back. And so the ability for somebody to walk up to something and learn it is in some cases harder than they should be. There's a very good book written by a gentleman whose name is Donald Norman called The Design of Everyday Things. And it's not about computers, it's about everyday things. So when you walk up to a door, does the door open in or out? Is the handle to turn it up or down? And good design says that the object should give you a hint. So if I walk up to a door, there's a handle, I'm probably going to pull it. And if there's a plate, I'm probably going to push it. So the next time you go to a door, before you go to the door, try and figure out if the door opens in or opens out. And very few doors tell you which way they open. Very few doors give you a hint. And good user experience, the ability for you to walk into a new situation and understand how to use the object, how to consume the object, really makes it as simple as you can to do that. And that stuff is really, really hard, because it's about psychology, sociology, anthropology, system design, industrial design, and just watching people. It's very hard to build user interfaces. Now, when you have a digital TV set, a set-top box, a DVD player, maybe you've got an amplifier, you've got more than one remote control. And the problem with this situation, and many homes look like this, is that each one of those remote controls are just a little bit different. And so you land up with all the controls, and some of them control 2 devices, some of them control 3 devices. And so the problem is, in many cases, as you add objects, as you add devices, your brain starts to go into overload. And you struggle, which remote am I using, and which button am I supposed to push? And so as the complexity increases, sometimes it becomes very difficult to add more devices. The brain's very interesting, though, because the brain, faced with a complex system, in many cases can simplify it, and simplify it dramatically. Now, do you remember when you learned how to drive? And your father was probably sitting next to you, yelling at you while you were learning because you were doing everything wrong. And the first time you were driving, you had one hand on the steering wheel, one hand on the gear shift, one hand on the accelerator, one hand on the clutch. And you had to coordinate all these moving parts. And it was very difficult and caused some tension in the family. But a year later or 2 years later, it's a completely natural thing for you to get into a car, start to drive, and probably reading your text messages, which you shouldn't be doing. But with the other hand, you're probably reading your text messages. So it turns out that the brain has the ability to adapt to complex systems in very, very interesting ways. Sometimes they're too complex, and sometimes the brain can simplify them. And so you get into this other model, which is instead of continuing to exponentially increase, the complexity decreases as you add devices. So some of the interesting work that we did early on the user experience on the phone. This is one of those simple innovations that seems so obvious, but nobody else thought about it. And most good innovations are like that. It's terribly obvious. And the thing that happened on the phone was, prior to this, the display space for the phone was that big. It was about 4 inches. If you had an iPhone, it was a little bit smaller. And all you could do was write the application to occupy that space. And the big innovation that happened here was we said, no, you can pan from left to right. And so the display space is still 4 inches high, but it's infinitely wide. And you can just expand by scrolling left or scrolling right. What that allows you to do is to build application frames that are infinitely long that allow you to put very complex computing interfaces onto a very small screen. Again, it's a fairly simple innovation, but it had never been done before this in any real way. Now, one of the interesting things we did on the phone, on the user experience, was most people on most phones walk around with their phones in front of them like this. They walk into people on the street, they walk into their family, they pay a lot of attention to what's going on the phone. And part of what we try to do in this design of the phone was simplify it so you could quickly look at your phone, see some messages, and move on. And so we created these things called live tiles. Each one of these tiles carries some information. So in the top box, you can see I've missed 2 calls. If you click on that button, you'll see which calls you moved. And so the tile is a very small display space in which you can send hints to people about the object. So I travel a lot. I have some tiles on my phone that is the state of my next flight. Tomorrow morning, I'm flying from here to Stockholm. Is my flight on time? Is it late? Do I need to change flights? Has it been canceled? All of that information is just conveyed through this live tile. So I don't have to load the application. I can just glance at the phone. And that's great most of the time. However, glancing at your phone while you're driving is not a good idea. So driving in your car, we had to find another way. So what we did in the car, and I remember that when this happened to me the first time, my phone, I was in the car and my phone was connected to the Bluetooth in my car. Suddenly, my phone started talking to me and said, hi, you have a text message from Lisa. Just talks to me in the car. I'm like, okay, should I read the text message? Go and reads me the text message, asks me if I want to reply. And so it's all done by voice in the car. Because in the car, you shouldn't be holding up your phone. The natural user interface in the car is through speech and not through vision and touch. So here's an interesting problem. Many of you are involved in branding and marketing and how to convey ideas. how do you describe this effect to people? How do you describe to consumers the idea that it's glance and go? You can look at your phone, see quickly what's going on and move on, or that it works simply in the interface. So I have another video here, hopefully it'll play, which is a 30-second commercial that ran in the US that's trying to convey this message of glance and go, and no longer you have to look at your phone. There's no English in it, there's only a little bit of English right at the end, but don't worry about it. It's more about the music and what people do. So let's see if we can play this video. No, hang on, could you stop it and start the video, the audio again? Natasha? Nastya? Nastya, I'm sorry. Natasha. Drag this back from here. Perfect, user interface.
Really? It's time for a phone to save us from our phones. New Windows Phone, designed to get you in and out and back to life.
So how you create in 30 seconds and communicate that. And this was the TV commercial that ran in the US when the phone was launched, actually, to come up with that communication. Next slide. There you go. So we saw, you've seen Connect. I'm sure some of you have even played with Connect. One of the interesting problems with Connect and the user interface is you need lots of room because you bounce around and you wave your hands a lot. And when you do that, it's amazing. What's incredible about a Connect is watching little kids adapt to it. Not you guys, but little kids, 5- and 6-year-olds. Because they walk up and you say to them, wave your hand. And before you know it, they're waving their hands and they're dancing and playing games. It's completely natural to them to integrate with these devices. It's absolutely amazing. But Connect, although it's an amazing user interface, and the software that sits behind Connect is absolutely amazing. There are skeletal models that when you move your hands, there's a model of your skeleton to know you've moved your hand like this, or you've rotated your elbow, your wrist. All of that is in the software. So the hardware is actually quite simple. It's all in the software in this case. But the interesting thing about Connect is you need space. So doing a Connect interface inside an aeroplane is kind of difficult. How do you jump around in an aeroplane seat? And so how do you create natural movement in a plane in interesting ways? And so what you discover when you build user interfaces is that everything is best for something and worst for something else, and good for some things and bad for other things, and natural and unnatural in lots of different ways. And designing user interfaces is really, really tough. So here's what the interesting point is. The interface, where is the real value? Is the value in a single device, or is the value in the ability for multiple devices and between the devices? So within one device or between devices? And that's what really starts to separate the user experiences a lot. Click. There you go. And so two concepts I'll talk about here, the user interface and the user experience. The user interface is what goes on one device, and the user experience is what goes on across devices. Windows Phone, Windows 8, and Xbox all have a consistent user experience. If you know how to use Metro, if you know how to use big blocks of live tiles and touch them, whether you're touching physically or touching through Connect or clicking with a mouse, if you know how to do that, the user experience is consistent across all of them. So when I introduce a new device that has that same level of interface, easy to learn. And so I'm going back to my earlier question about the simplicity of the interface and the ease of learning of the interface. And that's where we've probably spent a tremendous amount of research time, is thinking about the way people use systems and the way they integrate with systems and the way they do that in continuous ways. if my machine was down here, I'd actually do a Windows 8 demo now, but I'll talk about it. This is what search looks like on Windows 8. And when you go to the start screen, if you just start typing, the system knows that you're doing a search. And what it does on the side here is gives you a list of applications where this particular search is valid at any particular time. And so if you're trying to see the weather in Moscow, you type Moscow, hit the weather application. But if I want to see restaurants in Moscow, I'll type Moscow, I'll hit the restaurant application. Or if I just want to do searches on universities in Moscow, I'll type universities in Moscow and hit Bing, and it'll search the internet. So what's happened is that the way you search is exactly the same across every application on Windows 8. So the same way as I talked about the user experience being the same, in this case, search is exactly the same, has the same interface on Windows 8, no matter how you search, no matter what device you search, no matter what application you search. You just start typing is the way you basically search for things. One more video, and actually if the audio doesn't play here, don't worry, because this is a research project from the University of British Columbia in Vancouver, Canada. And it was some research that was being done about three-dimensional displays. So all the displays that I've showed you are two-dimensional. In this case, we want to show 3D displays. And what you're going to see is a little box. And that little box has 5 liquid crystal displays, 5 LCD displays, 4 on the side and 1 on the top. It also has a camera in it and a gyroscope. So it follows you where you are, and it knows the orientation of the devices you're turning it. And what it's doing is actually projecting pictures onto the LCD so that if you move, the camera knows that you've moved, and it gives you a different perspective. So the perspective that is shown on the device changes because you move, not because the device has moved. So watch this video. I mean, if you think about this, it's a very cheap device. It's just 5 LCDs, and it'll show 3D. And don't worry if there's no audio, I'll just let it play. So you can see inside you've got these multiple 3D. It looks completely 3D, but you know that it's only 2D screens. The objects can move in real time. The objects can move in space. You can also interact with the objects, so you can tilt it and move the football around. You can bounce objects in this space. You also have the ability to interact with the objects by taking a pointer in front of the camera and bounce the ball using the pointer. So this was a series of graduate students at this university that built this device. So if you think about, in this case, simplicity of building that device, we've shown mainly two-dimensional interfaces. What is the world going to look like on 3D interfaces? And so if you're doing a massive business intelligence where you're trying to understand some data, let's say on sales of a company, when you look at it from this side, you see sales by geography. When you look at it this side, you see sales by product. When you look at it this side, you see sales by salesman. And so how do you walk around the data? Because I can on this device. I can actually walk around the data in very interesting ways. So let's go from the user interface to the cloud. And we've learned a tremendous amount from the public clouds that Microsoft has, the work that we've been doing on clouds. The biggest cloud service that we have is actually Windows Update. Windows Update talks to every PC, every Windows phone, and every Windows server every day. Hello, how are you? Do you have a virus? Do you need a fix? Do you need a security patch? Every day. And if you have a Windows machine, you don't even know about that. But every day we're talking to billions of machines around the world to making sure that they're safe and secure and reliable. And so we've learned a lot from that, as well as Hotmail and Bing and Live and all these other services that we've got. And there are a couple of key things that come out of this. The underlying maturity of the processes, the simplicity of self-service. When you go to Hotmail and you want to add a Hotmail account, we have to make that absolutely bulletproof so that you can't mess it up. And I'm sure it never happens to you, but there's lots of other people who go to self-service portals and mess it up. And so one of the things that we've learned is self-service drives rigor on the implementation. This bottom one is the most interesting, which is what I'll call extreme standardization. Everything is the same. The hardware is the same, the software is the same, the CPUs are the same, the memory is the same, the wiring is the same, the network is the same. Everything in those larger data centers that we have is the same, including the software. So today, the Bing search engine runs on over 200,000 servers in more than one data center. Just think about that, 200,000 servers to run the Bing service, the search service. Across multiple data centers, it is absolutely identical. And what we've learned is the need to be able to do that and bring that down to the products that you use and that you develop in interesting ways. This is what a data center looks like. New data centers do not have a false floor. They don't have people wearing space outfits walking around. This is a data center with 50,000 servers in it. Each one of these containers, they're stacked one on top of the other, is a container that you would see on a train, you'd see it on a boat. Each one of those has 1,000 servers in it. Has a little door in the front, and that's about it. Sits inside a warehouse. The only things that are connected to the containers is power, water for cooling, and the internet. Now, when one of those servers fails, when a CPU fails or a disk drive fails, we don't stop everything, give somebody roller skates and have them go through and pick out the server. You can't do that when you have that many machines. So we just take that service, put it out of service and leave it there. And ultimately, when the rack is degraded, we send the container back to the manufacturer and say, fix it. You cannot, when you have millions of devices, you cannot fix devices in ones and twos. You have to look at them in a more whole. So the software has to be able to take devices in and out of service. There's two kinds of cloud applications. Symmetrical clouds, which means the same thing runs on a server as runs in the cloud. Mail is a good example. The mail for the university probably runs at a data center somewhere in the university. Hotmail runs in the cloud, Gmail runs in the cloud, Yahoo Mail, Live Mail. There's lots of mail systems that run in the cloud. You don't know where they are. When you access your email from your phone, you have no idea where your mail is running. If you have a Hotmail account, you cannot tell which data center you're running in. There's more than one Hotmail data center around the world, and you have no idea where it is. In fact, when you go look for it, you'll create a Heisenberg problem, and it'll probably move because we have to load balance it around the network in very broad ways. So that's symmetrical. Asymmetrical is where what's running on your device is different to what's happening in the cloud. And I'll give you an example. I talked earlier about voice interface to text messaging. When I want to send a text message on my phone and it records my voice, there is not enough CPU on the phone to do the voice recognition on the phone. It has to go to the cloud. So it takes the synthesized, the digitization of my voice, projects it to the cloud using something called VoiceML, which is a protocol, sends it to the cloud, and the cloud will do the transformation from this captured speech into text and send it back to me. You can't do that on the phone. The only way you can do that is in the cloud, and that's what I mean by asymmetrical. What happens in one device is different to what happens in the other device. And you have special purpose devices in that case in order to do that. So there's a very interesting way that solutions are going to be built in the future. Most of the product planning that we do as a company is based on personas. When we look at an application, we look very carefully to understand who are the users of this application, what characterizes one user from another. Let's use mail. Some people use mail through the website, some people use mail on a phone, some people use mail in a browser, some people use mail on an application. All of those people are personas of different types. Your mother probably uses mail different to the way that you do. And so you have to understand all of the personas who are going to consume this information. So personas have objectives. And the objectives can be business objectives or they can be personal objectives. And then they use devices, little devices, big devices, devices on wheels like your car, to consume solutions comprised of services running on an infrastructure. And then you'll come backwards. Is the infrastructure in the cloud or not in the cloud? What's the standard for the development of the services? How are the services aggregated into solutions? How often do the services change so that my solution changes? And the solutions architects, the system architects in technology today spend a tremendous amount of time at each one of these interfaces trying to understand how they should be implemented. What's the standards that they should use there, and how should that work be done? So together with that, the world of data is changing dramatically. We're generating huge amounts of data. Data is being produced and data is being consumed in unbelievable ways. This is the data on the web in 60 seconds. If you actually want to see how much junk, sometimes how much real things are created. 12,000 new ads are posted on Craigslist. 13,000 hours of music are streamed from Pandora. 370,000 minutes of voice calls on Skype. 98,000 tweets in 60 seconds. So just you think about how much stuff is created here. Some of it is valuable, some of it is less valuable. But what do you do with all of that data is really the interesting thing. Well, this is what the new world of data looks like. This is something you think you would produce in Excel. I'm sure many of you have produced graphs like this in Excel. But this is the new world of business intelligence, where this data is actually live. In other words, I can go in and I can manipulate the data, I can move the data, and I can model in real time the underlying system. And so, as a result of all of this information, we've had to really make the business intelligence systems more intelligent in the way that they consume, in the way they project data in very interesting ways. And so the road ahead for us kind of looks like this. It looks like that standard user experience running across multiple devices and looking at devices and how they communicate in the cloud. You've got Connect doing amazing things. I don't know if you've ever played with Connect. Just walk up and watch people. It's actually quite amazing. The Connect today is available in US pricing. I have no idea what the pricing is here, but in US pricing, it's about $200 for the device. And then there's an SDK, and you can start to develop in very, very, very interesting ways. And there's amazing work being done developing games on Connect and also developing business applications on Connect. I'll describe one of the games to you, and then we'll watch this another video. There's a game that was done with Sesame Street to teach children how to count. And a lot of children around the world learned how to speak language and learned how to count from Sesame Street in multiple languages around the world. But this game has changed it because the kid will sit in front of the Xbox with Connect, and one of the characters from Sesame Street is holding a box. And the character will say, "Why don't you throw a coconut into the box?" I don't know what you would do, but most kids go like this. They throw a coconut into the box. It's very natural for a kid to throw a coconut. And as they throw it in, a coconut appears in the box on the TV. And you can see the kid go in and look. And then Grover says, "Throw another coconut." Throw another coconut. And they have a conversation. There was one coconut, now there's two coconuts. Throw another coconut. And before you know it, the kid's throwing coconuts in, and the coconuts are piling up. But they're behaving in a very natural way with the device. And so there have been some phenomenal applications that have been done on Connect. And there's another video that shows you some of the things that are being done. Some of the things with virtual musical instruments, surgery being done, bomb scare being done. It's amazing. Just watch this video and let's see what happens. If the audio doesn't play, just Nastya, just do what you did before here. Okay, you're going to have to stop it and play the audio again. Drag it back. Good.
We started with a sensor. We started with a sensor that turned voice and movement into magic.
Xbox, play.
And we thought, this will be fun to play with. And it was. But something amazing is happening. The world is starting to imagine things we hadn't even thought of. Unexpected things. Helpful things. Beautiful things. Inspired things. Which is why, even though the world keeps asking us what we'll do with Connect next, we're just as excited to ask the world the same thing.
See, even if you just think about a surgeon who's in the middle of surgery, he's got his patient all cut open, there's blood all over the place, and they want to go have a look at an x-ray. And then they'll walk over today and they'll have to touch everything and become unsterile. So in this scenario, they stand in front of a screen and they just move back and forth. They can go like this to zoom and like that to zoom in. And this is really going to change the way people interact with technology. And as I said when we started, one of the big changes that's happening is computer interfaces are working back to an analog world from a digital world. It's about touch, it's about multi-touch, it's about voice, and it's about gesturing. Gesturing in interesting ways. So imagine going into a bank and somebody standing in front of an ATM wanting cash, waving, "Hi!" and the terminal waves back and it recognizes you. Because that's the way Xbox works today. When I walk up to Xbox, it recognizes me and logs me in. It recognizes me visually. And so my identity is who I am, which creates some interesting problems. What happens if somebody gets dressed up and looks like me? They put on funny red glasses and Xbox recognizes them. So there's some interesting things that come out of this. Let me just go back here. What's interesting here is really the sort of core vision of what I've been describing, which is that really, as a company and as an industry, we aspire to have continuous cloud services, on-premise clouds, private clouds, public clouds, for every person, every persona, every business, small businesses, medium businesses, large business, connecting their devices, little devices, big devices, television sets, cars, all the devices that they've got in different work styles and lifestyles. And that's really, I think, what the industry is headed towards and where the industry is going in sort of fairly dramatic ways. So then I added a section at the end of this, which was, I thought it would be useful for you, which is, I spent a lot of my time at Microsoft thinking about how to create leaders and how to create leadership. And it's an interesting discussion to think about skills and skills development. So I put this in sort of as a second section because I think it would be useful for you. When we talk about leaders and the attributes of leaders, we'll put it into 4 buckets. One is introspection. Introspection is, do you know who you are? Do you know what your strengths are? And do you know what your weaknesses are? And if I asked you to write that down today, could you do that? You don't have to do it now, but could you write down your strengths and also your weaknesses? We also think that leadership is about influence. Influence is getting other people to do things for you that they don't want to do. It's getting them to do things for you that's going to help you and not them. And it's very complicated on how to do that. We also think about innovation, doing things differently and doing different things. And then finally integration, which is pulling everything together. And so a place to start is a framework for knowledge. And we developed this thing called the T model, which says you have to decide where you want to have depth and where you want to have breadth. In English, the words are expertise and literacy. You cannot know everything about everything. You have to decide what you need to know about and what you can find out from other people. So one of the interesting implications of this is, what is your network? Who are the people who you can ask when you need help? Who are your trusted advisors? Who are the people who can help you with a financial problem? Who are the people who can help you with a technical problem? And there's the reverse of that, which is, because you're an expert in a certain area, who can you help? And it's very important to think about your skills, your expertise in this model. What are the things that you know? What are the things that you need to know? What are the things that you love to know because it's who you are? So maybe you love music, but that's not necessarily what you're going to do at school or at home or at work. So what are the things that you really want to know, and then who can you get them from? In the technology business, this T model has to go to two other things. It's not just about technology. It's about two other elements. The first one is business. You have to understand the business of your customers, the business of the people you're working with. If you think about something like email, why does a bank need email? Why does an insurance company need email? Well, an insurance company needs email because they generally handle it for policy approval and claim processing. Banks, on the other hand, use email for deals and making deals, either with their customers or with other companies. So you need to understand why people use technology in order to do it differently. And that's both the business view and the industry view. The other one that's in this is about design. It's about great design. Design can be industrial design, user interface design, or great system design. But not all technologists are good designers, and not all designers are good technologists. But it's the team that makes the real difference. So we really are, from a technology perspective, in an era of architectural discontinuities. What's happening is that the world of technology, as I said when we started, is changing dramatically. Technology always changes. Technology always moves ahead. And sometimes there are little steps, but where we are today, the changes in technology are massive. They'll settle down, there'll be smaller changes, and in 10 or 15 years' time, there'll be another set of major changes. But what we're going through today is very much like the introduction of the internet 15 years ago, PCs 15 years before that, and mainframes 15 or 20 years before that. This is one of the major discontinuities in the architecture of systems. And so architecture in general, system architecture, but even building architecture, is about a constrained degrees of freedom. In other words, taking an open-ended problem and constraining the problem so that it is manageable, constraining it so that people can understand it, constraining it so that the solutions are much easier to define. So architecture is really part art, part science, and more importantly, the balance between them. When you look and you talk to any designer who's built something, the first thing that they want to do is go back and do it again because they know what they did wrong. They know exactly how to improve it. And so architecture is this art of making things simple and easily understood. But it's also the science of making sure that everything integrates, everything ties together, and the interfaces are clearly defined. And what makes great architects is the people who can do the balance, the people who can do the art part, and the people who can do the science. So think about architecture in interesting ways. It's a language that's used to describe a system and tools to really help make decisions about that solution. Architecture is the wisdom of experience predicting uncertainty. Great architects, great designers are people who've done it before. There are some people who design great things the first time off, but architecture is really about synthesizing all of the information around you and really looking at what hasn't worked in the past, projecting what will work in the future, and designing around that. But architecture is also about visual simplicity. You will know a good design when you see one. You can look at a device, you can look at a building, you could look at a poem, you can look at a piece of paper, and you can tell beauty in it when you see it. And you know it when it's not. When you look at a building and sometimes you say that's not great architecture, the same is true of a system. When you look at a phone, you can tell immediately whether that's a great design or not. But what's a great design for you is not necessarily a great design for somebody else. Each design is for an audience and an audience in its way. So technical leadership is not knowing everything about everything. The background here is a Visio diagram of every Microsoft enterprise product. You cannot impossibly to know all the pieces. On this segment, if there's one message that you walk away with, this is very important. In any lifetime, we all have multiple careers. I've had multiple careers inside of Microsoft. I've been there about 22 years, but I worked for Exxon before that. I worked in Canada. I worked in the US with them. I did a little bit overseas. So in every lifetime, you have multiple careers. And when you take on a new career, think about that career in 4 stages. The first stage is you're an apprentice. You're learning the job. You're new to the job. You really are trying to understand that job. The second phase is what's called a journeyman, which means you're an expert in the job. You know exactly how to do the job. And here's where the gap occurs. Phase 3 is about success through others. It's not about what you do, but how you make other people successful. And stage 4 is about strategy, success through strategy. Now those top 2 stages, not everybody can do them, and not everybody has to do them, because they can actually be quite stressful. But the biggest mistake that we all make is we take somebody who's a great developer, or somebody who's a great designer, and we say, because you're a great developer, I'm going to make you a development manager. And it's the worst thing that we could do. Because not everybody is a good manager. Everybody can be a great individual contributor, but it's not necessarily a goal to be a manager. It's interesting because in some cultures, in India, for example, in some cases in China, it's very important family and cultural to be a manager, to have people working for you. But I see too many people failing in that. And so what happens is that there's a chasm created in the middle between people who do great work themselves, who are very important, and people who get success through others. Microsoft is a very interesting company to work for because we have many people in our senior executives who are individual contributors. They do the thing that they want to do. If you actually drop to technology, the guy who actually designed the threading model underneath Windows NT is an individual contributor. He's one of our most senior technical people. But he's not a manager. He'd be a terrible manager. Being a manager is complicated. But getting success through others, how do you make other people successful? What are you doing to make others successful? So I'm sure in many of your projects, they're team-oriented projects, where you've got to work together as a team and deliver something. And in many cases, your lecturers and your professors are watching how the team behaves. Who leads, who follows, who makes the decisions, who presents. Those are all very important aspects of the team dynamic. I'm not going to go through all of these. I've got some at the end, but these are some of the behaviors that we expect from leaders. You need to be innovative. You need to be visible. You need to drive impact. You need to know your customer. You need to know balance. You can decide what the balance is, but you have to know the balance. I'll go through some of the key ones. I'm just going to flip through this quickly. You need to be able to drive your own success. Nobody's going to do that for you. Be aware. Be self-critical. I pulled a couple of these out because I think they're important. One of them is listening. Listen to everything. Listen to everybody. Synthesize what they say. Everybody has something to say. You can disagree with it. You can argue with it. But every time you listen to somebody, you learn something. And what makes great leaders is the ability to take that information and synthesize that with the rest of the information that you've got. Continually listen, take input, listen, take input. It's one of the reasons that I love doing sessions like this is because every time you ask a question, that means that we're not explaining ourselves properly, you don't understand what we're doing, and so I'm trying to understand. I'll answer the question, but I'm very interested in why are you asking this question? What is it that you don't understand with the question? So, first thing is listen. Next thing, be visible. Be visible means have an opinion, talk about your stuff, be present in the meeting, listen to the meeting, contribute into the meeting, contribute into your group. Be a participant. Don't watch. Be active and be a participant. One more. Have an opinion. As you listen to everybody and you watch around you, you need to formulate an opinion. It's one of the things I'll always ask people is, what do you think? And when I know what you think and everybody else in the room thinks, I can then think about, so what do I think is the answer? Do I believe you? Do I disagree with you? Formulating an opinion and having an opinion is incredibly important. It's about leading and not following. Followers don't have an opinion. Leaders formulate opinions. It's one of the ways to tell the key differences between them. And then this is my favorite picture, which is about having courage, which is when you have an opinion, you have to have the courage to stand up in front of everybody and tell them what you think. And every one of you in some way or another is going to stand on this stage or another stage that looks like this, and you're going to have the courage to have an opinion. You're going to have to stand in front of everybody and tell them what you think. Even though you might be wrong, even though you're uncomfortable. Your job is to convince people that you understand the problem, you understand their problem, and you've got the best solution to that problem. It's very important to be able to do that. And only that comes from courage. Having an opinion without telling anybody about it makes absolutely no sense. So you have to have the opinion and have the courage to talk about it. This is the last piece, and it's actually really important. You have to know what you believe in. If you just think about that, and I'll ask you, what is it the things that you believe in? What is it the things that you think are important? And here's why I think this is important. When you have to make a decision, it's generally quite easy. You look at the logic, you look at the data that you've got, you synthesize it, and you give an answer. 5, 3, blue. But you give an answer based on logic. But when you're under stress, when you're hard-pressed to give an answer, what happens is that your mind goes back to your core values. What are the values that you believe in? And in mathematical terms, that becomes the axioms of how you make decisions. And from the axioms flow the theorems. So when you think about what you believe in, that's how you make decisions. When you're under pressure and you have to make a decision, the criteria that you've got is really about what are the things that you believe in. And so one of the things you should do when you go home tonight, try and make a list of what is it the things that you believe in. What are the top 3 things you believe in? Family, to some people, is important. Integrity. Faith, maybe. Your health. If someone's been sick in your family, health is important. What are the things that you think are important? So I wrote down the things that I think are important. These are very personal. This is about me. Nothing else. It's not necessarily right or wrong, but it's about me. And it says, firstly, I'm a technologist. I'm a geek. I love technology. So I believe in the magic of technology and what you can do. I believe in the power of the customer and the power of the customer to tell us that our products are terrible. I think that's very important. I believe in the power of teams of people, but I also believe in individuals being able to do incredible things together. I believe in family. I believe in diversity. I love the fact that this is a diverse audience, that there's lots of men and lots of women. That's fantastic, fantastic to see, because diverse groups produce better answers. Statistically, we know that that is absolutely true. I like learning and explaining. I have fun doing it. I like doing it. I like transparency, explaining why I do things, and the power of connecting people together and connecting community. And really, it's about what you do together. That's who defines me. Not necessarily you, but that's who defines me. So think about it when you go home. Think about what you believe in, because that's what's going to help you drive the decision. So when we think about creating technical leaders and technical people, these are the kinds of questions that we ask. What have you done to make other people special? What have you done to make other people successful? What do you believe in? What are your values? What are the behaviors that you explain? Who are you? Can you answer these questions for yourself? Who are you? What are you? What do you believe? And what have you done? So I interview a lot of new hires into Microsoft, and one of the questions I always ask them, tell me what you've done. And I don't care whether it's what you've done at school, what you've done at home, what you've done in your church, what you've done in your football team. Tell me what you have done. And you better have done something, otherwise I'm not terribly interested. I want to know what you have done. You've had so many years on this earth, and what have you done to put value back in? And that's very, very important for me, and I think it's important for you as well. And so, let me close on this sequence. Imagine a different world. Imagine a world where every surface is a display. And we've started to see that, and that's going to change fairly dramatically. Imagine a world where your sugar content in your blood, you no longer have to prick your finger, but it can come from a contact lens sitting in your eye without having to change anything. Imagine a world where you have a meeting in a room with somebody, and the meeting room takes the minutes. And the meeting room sends you the notes from the meeting, because the meeting room can hear what you say, it can hear all the conversation you had, it can take the points, put them into email, and send them to you. Because the meeting room is a smart meeting room. And so the world starts to get a little different. So think about your life in interesting ways. Think about your life at home and how technology is going to change your life at home. Think about on the go, how you travel, how dependent you are on your cell phone when you travel to tell you to be able to communicate and collaborate with your family and your friends. And think about how it's going to be different in the classroom. Imagine what a classroom is going to look like in 10 years' time. So when you go from there and think about work and what work looks like, where instead of searching for things, you think about doing things. It's not about looking for information, it's about doing something with that information. Where digital realities augment the world around you, where you can hold up your camera and it'll superimpose a map on top of the picture. Or when you walk over to a restaurant, you hold up your phone at the restaurant and it gives you the ratings of the restaurant. It'll tell you what TripAdvisor said about that particular restaurant. And where mobile actually means more than a device. Mobile is where the device becomes your boarding pass on a plane today. But mobile tends to be something dramatically more than the world away. But think about then when you play. And there's lots and lots of ways that you can play. You can be part of the game, like I described that little girl playing with Sesame Street. You can be at the game and integrating with the game at the sports stadium. But really we think about the redefinition of entertainment, the redefinition of media, and the redefinition, as you saw in that little 3D application, how our applications are going to change. And imagine playing 3D games instead of 2D games in very, very different ways. And then finally, think about people. And people are about sharing experiences, where it's experiences in this classroom, experiences at home, experiences in work, experiences with people, and how you create memories of those experiences, and whether those memories are pictures, whether those memories are where you've been. Think about those particular memories. On this trip that we're on, this is now day 10, and I've been in 7 airports in 10 days. And so if you go to me on Facebook, you'll actually see every airport that I've been to as I continue to move around Europe on this particular trip. Those all become memories, and they're memories for me, but they're also memories for my family and memory for my friends at home who are following me as I go on this particular trip, and really become part of the global community in the way that you can tell people where you are and they can be part of your life, and you can be part of their life, even though you're not necessarily physically there. And so what we found is the best way to predict the future is to invent it. You've got to think about what the future looks like. That is your job. We've done our part. I'm one of these older guys who's been in this technology for a long time, but your job is to invent the future. My job is to talk to you about the possibilities of it. But it's going to be up to you in your ability to do that. And so the road ahead, I think, is actually pretty interesting for all of you. You have this incredible opportunity to change the world in the way you create technology, in the way you change the way people interact with one another, and really lose the constraints that many of us had with technology. And it's your ability to change the world and your responsibility to change the world for the people who are going to come after you. Thank you. You've got time? So we have some time for questions if you want. We'll work through any questions about anything. Microsoft, not Microsoft. Yes?
Using mic, please.
I want to ask about the learning process for children in schools.
Yes.
What about your children, how they learn? How it differs from our pupils, okay?
Yep. My children are not a good example, I'm afraid, because my children are 26 and 22. But even between the two of them, they're completely different in the way they use technology. My youngest daughter, who's in almost a different generation, lives and breathes in the technology. But when things go wrong, I'm the help desk. She calls me to fix the problem. My older daughter is quite different. She's actually very good from a technology perspective, but she works with autistic children. And so something like Connect for her with children, autistic children, is absolutely fantastic. But if you actually go to the way kids are in kindergarten or early grades today, they don't really know what books are. To them, content is multimedia content. It's about text, it's about voice, it's about touch. And so the way children today are interacting with content is very different to the way you or I might have interacted with content in different ways. If I was doing research, when I was at graduate school, I would go into the library and spend hours in the library looking through books and reading through books. Now you just sit as a search engine. You never leave your desk. You actually don't talk to anybody. You sit at your desk and you search. You search in Bing or Google or whatever it is. But that's good because the amount of content that you have access to is huge. One of the things I worry about is your brain is not filtering that content. Just because it comes back in a browser, you assume it's good content, which is not always true. The amount of content that's on the web, some of it is good content, but some of it is not that good. And the ability to have the judgment about what is good or not, we're losing that because everybody believes it comes in a browser, it's on the internet, therefore it has to be good. Not always true. And so I worry a little bit in the modern world about the way content is presented, the way content is learned, and we're losing some of that judgment to be able to look at the content critically and believe it or not. And so the first thing I'll look at is, does this make sense? I'll do a little bit of a sniff test, a smell test. Does this thing smell a little fishy or not? And that helps a lot. And so I think the way people are learning today as a consequence of that is changing. I don't know if it's better. It's definitely different. There's lots of good things where people, there are programs to learn mathematics, for example, that are computerized and process-driven and step-by-step. That makes it easier for people to learn at different frequencies, to learn quicker or slower. That's one of the real values of technology, is the ability of the books, whatever the books are, to adapt to the user. But when today's, the kids who are 6 years old and 10 years old, when they're in the workforce in 10 or 15 years' time, it'll be very different. Just think about 10 or 15 years ago. Where were you 10 years ago? And what devices were you using? You didn't have a cell phone. Imagine your life without a cell phone. Could you believe that? You lived without a cell phone. It's incredible. We used to have these things called CDs. And then before CDs, we actually had LPs. I have some at home still. And so 10 years is a long time from a technology perspective. So when the kids today are working and buying cars and traveling around the world, their expectations are going to be very different than yours or than mine would be. It's going to continue to change. I think it's just starting. I think the rate of change, what I said when we started off, the rate of change is only going to get faster. The thing I worry about in this case, in some cases, is what happens if you cannot keep up? What if you cannot keep up with the change? Where do you go? Do you go to an island somewhere and go blind the sun maybe? I worry about that. If you can't keep up, what's going to happen? And I think we're going to leave some people behind. Bad idea, but I think it'll happen. Okay? Question here?
Hello, my name is Sergey.
Hi.
I wanted to ask you, you told that Microsoft has a different model of making money, that instead of Apple, for example, that they make money when they make money.
Yes.
Microsoft make money every time somebody turns on Windows. What did you mean by that?
Okay, so the Apple makes money when they sell a Mac, or when they sell an iPad, or when they sell an iPhone or an iPod. That's when Apple has their primary revenue. They're fully integrated on all the pieces. We make money when you buy a PC from Dell or from Lenovo and run an application built by Symantec. So when the whole ecosystem works is what the Windows ecosystem is about. In the case of Xbox, the ecosystem is the people who develop games. In the case of Windows, the ecosystem is the people who develop hardware and the people who develop software. So the Windows ecosystem is a very broad ecosystem. The Mac ecosystem is not, and the Google ecosystem is different as well. Each one of those are different. The same with the Amazon ecosystem. Each one of those has different characteristics of where the revenue stream is. In the case of Google, the revenue stream is from advertising. Everything else is free. It's all about advertising and you giving them your context for free. You give Google your context. You say, my context, and the reason you give it to them is because you get better search. That's the reason why. And then Google makes money. When you click on search, that's when Google makes money. And that's very different to the Apple model, the Microsoft model, the Amazon model. So each one of these companies is different to the IBM model. Each one of them has a unique way of making money in the marketplace. And they're all different, and they all kind of work together. They kind of coexist. Some are better than others. Some change. Some move along. But they're all different. They all seem to work. And if you were to do a startup today, one of the things you'd have to decide, what's the business model that you're going to have. And so I see a lot of people who have new ideas in startups, and they'll come and talk to me. And the first thing I say to them is, how do you make money? And I've got some technical guy saying, but I've got this beautiful design, it has a shared memory model, it runs distributed. I'm like, okay, that's great, but how do you make money? Because in the end, nobody's going to pay you. If you have all the money in the world and you can do it for free, you're lucky. But most people, want to somehow feed their children and have a house. So how do you make money? Second thing I'll ask a startup is, what's your second idea? Because if you think your first idea is your only idea, that'll never happen. Because your first idea has a half-life of about 6 months before somebody else has done something that's better than what you did. Because as soon as you show it off, there's lots of people watching. That's what the internet is about. And what's fascinating about the internet is, you develop it here, there's somebody in Guatemala or in Mexico or in Canada or in Latin America or in China who's watching. And they have the ability to take your idea and do something different and better. So you always have to be thinking about more than one thing, or taking the idea that you've got and expanding it in some way. And so if you can't tell me how you make money or what your second idea is, I'm not interested in talking to you. It's all part of the businesses, the ecosystem.
Can I ask you the second part of this question?
Sure.
How do you think why the Apple model of making money idea is so prosperous?
So right now, Apple's model is really about the margin.
They've made their share cost more than $600 now.
Yeah, but that doesn't mean anything, because that's all, the share price depends on how many times they've split. So it's really the market cap. The individual share price doesn't really matter. Warren Buffett's company has a share price of $12,000. The share price doesn't matter. It's the overall market cap that matters. And Apple has the high market cap. So not share price, it's market cap. Today, Apple makes a bundle of money because the margin on their hardware is huge. The profit that they make on their hardware is massive. Thing one. Thing two, if you put something in the Apple Mac in the App Store, they take 30% off the top. Most companies don't have that much margin in their business. Apple takes 30%. If you want to be in it, they take 30%. You don't want to be in it, goodbye, 30%. They determine the price of the books, and there's some investigations that are going on right now about that. So Apple's margins are really high. They make beautiful devices. The engineering is fantastic. Are they the best devices? We could actually decide that later on. Let's wait for Windows 8 to ship, and when Windows 8 ships on tablets, we can have that debate. We think next year we'll ship about 300 million Windows 8 devices. More than any number of iPads. iPads have shipped about 50 million. We think we'll sell about 300 million Windows 8 devices next year. So the world will change. The world will be different. But Apple's profitability, they've always had high profitability. Their profitability because they make beautiful devices and they charge a lot of money. And you pay it. So if you have an iPad 2, do you have an iPad 2? You're going to buy an iPad HD? What are you going to do with your iPad 2? Exactly. It's called creative disposal. And really, there's not that much different between the iPad 2 and the iPad HD. The display has a higher resolution, slightly better battery life. But then there's going to be an iPad 3 that's going to come out in October. Then what are you going to do? Give your HD to somebody? So they make money because you're buying the new ones every time. And you're lining up, you're standing outside the Apple store at midnight, freezing, waiting. Because you're willing to pay that and you're willing to do it. They make lots of money. Psychologically, it's very interesting to understand the differences between them. One thing you probably don't remember was when Windows 95 was released, same thing happened. People were lined up, queued up outside in the cold to buy Windows 95 15 years ago. You probably don't remember that. So it comes and goes. There'll be others. The technology market's about cycles. Need a cut. We're done? Thank you very much.
Спасибо. Коллеги, спасибо.